Hello and welcome to our discussion about college algebra. Today we're going to talk about properties of functions. In our current textbook, this would be section 3.4, Sullivan's College Algebra. And honestly, we're going to do a lot of this lesson out of the textbook. So we're going to start off by looking at an example. A bunch of examples. This is the first set of problems from section 3.3. So we're going to look at these. These are all in reference to this graph. So in essence, it's a lot like 3.2 where we were interpreting the graph of a function. We're going to start off by doing the same things. So in this one, we're going to talk about increasing or decreasing and maximums and minimums. Most of this is pretty intuitive. That's why I'm just starting from the graph, starting from the example. So let's see here. Is f increasing or decreasing on the interval? Well, increasing or decreasing is a very simple concept. It really corresponds to slope when we're talking about slope of a line. A line has positive slope if, as you're going left to right, it goes up. A line has negative slope if, as you're going left to right, it goes down. So that's actually increasing or decreasing. Increasing or decreasing. A function is increasing if its graph is going up as you go left to right, or more precisely, if as your x increases, your y increases. And decreasing if as your x increases, your y decreases. So it first asks, is f increasing on the interval -8 to -2? Well, this is an interval of x. It's an interval of the domain. So if you start at -8, which is right here, and you go to -2, which is right here, and you look at what the function does. It is going up as we go left to right. So the answer to this one is yes. This one, -8 to -4, is it decreasing? Well, just because that's the subset of the last one, the answer would be no, but you can also just look at here and say, well, no, it's not. But let's actually skip down to 17 and 18. See if you can answer this just by yourself first. List the intervals on which it's increasing and which it is decreasing. So 17 and 18. So increasing, pause your video and try it yourself. Then I'll write it out here. It certainly won't take very long either way. Well, increasing, we already know it's increasing from -8 to -2. So I can include that one, of course. Then, where else is it going up as you go left to right? Well, not here to here, not here to here, but from 0 to 2. And, let's see, from 5 to 7. So a lot of commas, but we got the whole list. I believe that's everywhere where it's going up. Note you should always have parentheses on your intervals. You never increase or decrease at a single point, so your endpoints should always have parentheses. I've actually seen some books disagree about that. They're wrong. It causes you lots of problems in other areas if you allow increase or decrease at the endpoints. I've actually been to sessions at mathematical conferences about that. Anyway, on 18, if we look at decreasing, as before, try it yourself. This is actually going to be pretty simple considering what we've already done in the first one here, because now if you look, where it's decreasing is in between all the places where it was increasing. So we have -10 to -8. We have -2 to 0. And we have 2 to 5. Note that this isn't the only thing a function could do. It could also not be increasing or decreasing. It could just be constant, in which case it would just be a flat line. It wouldn't go up or down. It would just be flat. Let's talk about these minimum and maximum questions. So a local minimum or maximum is just the largest or smallest point in a small interval. So, for example, see here, you have this little trough here, this bottom of the valley. This is a local minimum because it is the smallest point in an interval around it. There's also a local minimum here and a local minimum here. So there's 3 valleys, 3 local minimums. So in 22, where it asks where are the local minimums, in 22, when it asks where are the local minimums, we would say local mins at x equal, let's see, -8, 0, and 5. And then the value of the local minimum is actually the y value, because remember, when we first started using function notation, the function notation was the replacement for y. So when it asks what is the value of the function there, it's asking what is the y value. So we would say the value, the min value, is, well, at -8 it is -4, at 0 it is 0, and at 5 it is also 0. Similarly, if we look at maximums, local max at x equal, see, the places where it has a local maximum are at -2, at +2, and then their value, is that the only places? I mean, they have little crests at the end, but it has to actually have an open interval around it to be a local maximum or minimum, so it'd have to have something to the right of this endpoint and something to the left of this endpoint to be a local. The general term for either a maximum or a minimum is called an extremum, or in plural is extrema, so local extrema would be local maximums or minimums. Our book doesn't actually seem to use that terminology that much, but there it is, in case you ever see it used. Extrema is a maximum or a minimum. So let's see here. The maximum values would be, let's see, 6 at -2 and 10 at +2. Then we have our absolute minimum and maximum. So absolute minimum, well, for that, it is the largest value of the function on its domain. And they actually specify where the domain is, -10 to 7, which is just this. If it continued onward, if we had a larger domain, who knows, possibly there might be a larger highest value or a smaller lowest value. But you can see from the graph, both of these extrema, these absolute extrema, are attained at local extrema. The absolute maximum, the highest value of the function, is up here. You can tell from the graph, there's no higher point. So we would say on 24, absolute max is 10, and it's found, it doesn't actually ask where it's found, but I'll go ahead and say it's found at x equal 2. And then, space, I guess I'll put 23 here. 23. Absolute minimum. So the absolute minimum is found at -8, and the absolute minimum is 4. So absolute min is 4, and it is at x equal, not 4, -4. -4. At x equal -8. And there we go. That's how maximums and minimums work. And that's how the increasing or decreasing works. Let's continue on and look at some functions. Some more graphs. If you look at these, you can look at intervals in which the function is increasing, decreasing, or constant. Here it's increasing from -2 to 0, increasing from 2 to 4, decreasing from -4 to -2, decreasing from 0 to 2, and so on for all of these. This function is actually looks like it's increasing from -infinity to infinity. Looks like it's always increasing. Same thing on this one. As you go left to right, looks like it's always increasing. We could find domain and range as well. I mean, range of, say, this one is infinity. Is 0 to infinity, and domain, it looks like just -3 to 3, including the 3's. This would the range would include the 0 as well, but obviously you can't include infinity, so that would get a parentheses. But the 3 would get a bracket. Yeah, I wanted to look at a couple of these problems. Find the absolute maximum, absolute minimum, and any local max or local minimum. So let's look at 54 here. We can tell it has an absolute max of 4 at x equal 2. What's its absolute minimum? Think about it for a second. Pause the video if you want to roll it around a bit in your head. But yeah, this goes down infinitely. You can tell from the arrows, so there is no absolute minimum. It has a relative, or sorry, a local max. They're also called relative maximums and minimums. Local max of 4 at x equal 2. Local minimum of 2 at x equal 0. I want to look at this as well, mainly just to talk about the absolute extrema. If we look at 49, absolute max, well, where is it? It's not at a local max this time. Absolute max is actually at the endpoint. So absolute max of 4 at x equal 1. And just to finish this off orally, I'll write it. I don't need to be lazy. Absolute minimum is at the other endpoint of 1 at x equal 5. So a local maximum or minimum will never be at an endpoint, but an absolute max or minimum absolutely can be. It's just the highest or lowest point, so it doesn't matter what kind of point it is. Absolute maximum or absolute minimum is just the highest or lowest place, so that might be at an endpoint if it has a restricted domain. There's actually a law in mathematics that says if you have a continuous function, no breaks on a closed interval, it includes its endpoints. You have to have an absolute maximum and an absolute minimum, and it's always at either the endpoints or local extrema. So the last set of examples I really want to look at are things like 52, 55, and 56. Now if you look here at this point here, you notice it has an empty point. What does that mean? Well, that means the function, the graph, does not include that point. It's an empty point. It goes up to but doesn't include it. Well, that's going to affect our absolute max and absolute min. Because if we think about our absolute max would be at that point, but that point isn't on our function. So we have a maximum bound the function is approaching, but does not reach. So what does that mean? It means there isn't one, because they removed the only point where it could be. If it was filled in, if it was filled in all the way, sure, we could use that point. But it's not, so there's no absolute maximum. There is an absolute minimum, because this point is included. It's already filled in, so absolute minimum of 1 at x equals 0. There's also, let's see, local maximums. There is no local maximum because the only place where it could be is not included. There is no local minimum because there's not even really a place where it could be. And if you look at something like this, 55 here, is there an absolute maximum? Well, the only place it could be is right here, not included, no absolute maximum. Is there an absolute minimum? The only place it could be is right here, not included, no absolute minimum. How about local? Well, again, the only place you could have a local maximum is right here, not included. Only place you could have a local minimum is right here, not included. So no, 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 and no. Alright, that's where we're going to end this first video on properties of functions. We don't have a whole lot left to talk about. We'll talk about even and odd functions, and then we'll do some of these problems down here as well, where we use our grapher to find maximum and minimum values. We'll try and keep the rest of the videos pretty short. 3, 4 should have a similar length. 3, 5 may be a little bit longer because of some of the stuff we have to do in there. And 3, 6 applications, so it just depends on how long the examples take. But yeah, we'll see how this works. I'll probably see you at one of our Q&A sections, or if you can't attend those, I'll see you in the next video. Have a great day.